Every time a new AI model launches, there's a number. 92% on this, 88% on that. State-of-the-art on something with an acronym. The number is supposed to tell you how good the model is, and most of the work that produced it never makes it into the headline. This video is a small toolkit. 6 places a benchmark score can mislead you, and 7 questions you can ask the next time you see one. Not as a debunking. Benchmarks are often the best thing we have, but so you can decide for yourself how impressed to be. A benchmark, stripped down, is 3 things. A fixed test set, a list of questions or tasks someone wrote down. Take MMLU, which you have probably seen quoted. 57 subjects, around 14,000 multiple-choice questions, from elementary math to professional law. That is the test set. The second thing is a prompt format. How you hand each question to the model, the wording, the system message, whether you give worked examples first, whether you let it think out loud. And the third is a scoring rule. How you turn the answer into a number. Change any one of those and you get a different score. Same model, same questions, different number. Most arguments about benchmarks are really arguments about one of these 3 boxes. Trap 1 is contamination. Modern models are trained on a huge slice of the internet. Many benchmarks have been on the internet for years. So sometimes a model isn't solving a question, it's recognizing it. Honest evaluations defend against this. The holdout test sets the model was not allowed to see. They run decontamination checks against the training data. Some benchmarks, like Big Bench, embed unique strings called canaries, so labs can scan their training data and see if any questions leaked in. What to look for: was the test set published after the model's training cutoff, and did the lab run a contamination check? If both answers are, I don't know, your prior on the score should be a little weaker. Trap 2 is the ceiling. The first generation of a benchmark might land models in the 60s or 70s. A few years later, every frontier model score is above 90. At that point, the benchmark isn't really measuring capability anymore. It's measuring whichever last few % of questions happen to be ambiguous, badly worded, or have wrong answer keys. The difference between 94 and 95 might just be noise. Near-saturated benchmarks are popular in announcements because every gain looks dramatic on a chart that ends close to 100. What to look for? Where is this benchmark on its progress curve? If everyone is already near the top, the headline number is closer to a tiebreaker than a measurement. Trap 3 is hiding inside the word average. A score like 92 on a multi-subject benchmark is a number for an imaginary average user. A real user has a specific question. A model that's 92 overall can be 99 on ethics, 96 on history, and 78 on physics. And if you came for physics, that overall number was the wrong number for your task. The fix is almost always to find the subscores. Most reputable benchmarks publish them. Many summaries don't. What to look for: a breakdown by category, and especially the worst category. The shape of the score is often more informative than its mean. Trap 4 is the gap between the benchmark and the task. The same question can be asked as a multiple-choice problem, as a free response question, or as a tool use task, and the same model will give you noticeably different scores on each. Small changes to the prompt, how many examples you give, whether you allow chain of thought, even the exact wording of the instruction, can move scores by several points, and sometimes much more. So when you see Model X gets 89 on benchmark Y, what you're really seeing is Model X gets 89 on benchmark Y when prompted in this specific way. If the prompt isn't published, you don't really know what you're comparing. Trap 5 is grading. For multiple-choice tests, this is easy. For free response, code, or open-ended writing, somebody has to decide whether the answer is good. Sometimes it's a human. Sometimes it's another model. If the grader is itself an AI, it has its own preferences and its own blind spots, and those quietly leak into the score. In an earlier video on this channel, I ran an experiment where just flipping the author label on an essay shifted the grade by about 1/3 of a point on a 10-point scale for the same essay. The link is in the description. So when a model is the judge, how good is this answer becomes partly how much does the judge like this kind of answer. What to look for is the grader a model, a human pool, or a strict rubric. And if it's a model, what is its relationship to the model being graded? Trap 6 is the number of attempts. A benchmark score in a launch post can be a single run. Run the same model on the same benchmark with different random seeds, and the score wobbles, typically by 1 to a few points just from sampling. In other cases, the reported number can be the best of several runs, or the result with the most favorable prompt out of many tried. That doesn't mean the result is fake. Variation is normal, and these choices aren't always disclosed. It does mean the headline number is closer to a maximum than to a mean. What to look for: confidence intervals, the number of runs, and whether the lab published the worst run, not only the best one. That's 6 traps. Here, they are as 7 questions you can keep in your head. What's in the test set, and could the model have seen it? Is the benchmark near saturation? Is there a subscore breakdown? What prompt format, and how many examples? Who or what graded the answers? How many runs, and how much do they vary? And the question that quietly matters most: what does this benchmark not measure? Most benchmarks measure something narrow. Many of the things we care about, long horizon reasoning, real-world reliability, behavior under pressure, are still hard to test. The goal here is not to make you distrust every number you see. Benchmarks are useful. Many are carefully built. Some labs report them in detail and honestly. The goal is to put the number in context, to remember that a score is a measurement, and measurements have setups, and setups make choices, and choices change the answer. Once you can see those choices, the story behind a headline gets more interesting and usually more accurate. Description has links to the benchmarks I mentioned and to the prior research on grader effects. Thanks for watching.